Today we're going to look at the next attribute of a line segment, slope. Slope is an extremely important descriptor of many items, including in physics. So it is really important that we get slope correct. Slope of a line segment. The slope of a line segment is a number representing the rate of change of a line segment and is given as the vertical change divided by a horizontal change. Slope is usually expressed as a fraction. For example, what will slope do? There. This line segment is very steep. So I'm going to attach a number to it because it's going uphill steep, 4. I made that number up, 4. It doesn't have any meaning yet. However, I can still go uphill, but that is not as steep. So sometimes I might call this slope 1/2. So this number will indicate how steep something is. Not only will this number indicate how steep something is, and by the way, those two examples, we were both going uphill, what it will also do, it will tell the direction of steepness. So as we read right to left, I would argue, hey, that's still steep. But this is steep downhill, so it might have a slope of -4. And another value here, there's a line segment with 2 endpoints. This is less steep, but still downhill, moving left to right. So it's going to have a negative value, but it's going to be a low negative value. So slope is going to be interpreted as this. It is the vertical change divided by the horizontal change. Sometimes you will see this as the slope is equal to the change in y, which y measures vertical over a change in x. A line, let's start here now. A line rising to the right will have a positive slope, while a line falling to the right will have a negative slope. I always find that we should read a graph left to right. We're going to move left to right. And as we move left to right, if we go uphill, that's a positive slope. But as we move left to right, if we go downhill, that's a negative slope. All right. Example 1. Determine the slope of a line segment with endpoints -1, 2, and 5, 7. So what we're going to do is we're going to graph the line segment. That's the first thing that we're going to do. That didn't work. There. And again, I'm just going to call my endpoints A, B, just to give me a frame of reference if I want to talk about it. We're going to create a right angle just like what we did with distance. So they're parallel to the horizontal and the vertical axis, the x and y axis. There we are. Now, I'm going to change this color to maybe blue. So, determine the lengths of the legs. So, the horizontal leg, or the red leg, I'm going to count out as 1, 2, 3, 4, 5, 6. It's 6 units long. Whereas the blue leg is going to be 1, 2, 3, 4, 5. It's 5 units. And if you think about it, moving from in the x direction, -1 to 5, that will be 6 units of change. Moving 2 to 7 will be 5 units of change. We're going to identify the vertical change. The vertical change here is 5. The horizontal change is 6. Identify whether this relationship is increasing or decreasing. While we say a function is increasing, is that as you move, again, left to right, this is going uphill. So this function is going to be increasing. So it will have a positive slope. Now, when we take a look, state the slope. Well, the slope is going to be equal to my vertical change, which is 5, over my horizontal change, which is 6. Next question. Determine the slope of a line segment that has endpoints -7, 3. And 4, -2. So there's my endpoints of my line segment. Now I need to try to connect that line segment. There we are. I think I did a relatively good job. To help me out, I just call this A and B. Now A and B just helps me keep track of things. So I'm going to make a right angle triangle here. So first thing I'm going to do is I'm going to make the legs. The next thing I'm going to do is I'm going to identify the change, the vertical change. And what I'm going to say as I move from A to B, well, we go from 3 to -2. So there was a change of actually -5. That is, Y went down 5 units. Now the horizontal change, the X went from -7 to 4. You can count those out. However, -7 to 4, that changes by 11 units. If we notice, this is going, as we go from left to right, this is going to be going downhill, or we call it a decreasing function. So that means that the slope will be negative. So we're just going to write slope is the vertical change over my horizontal change. I could think of it as my change of Y over my change of X. And what I notice is that this slope has to be negative. But thankfully, my change of Y, or that arm, that vertical change, is -5 over the horizontal change, which is 11. So my slope here is -5 over 11.